All right, let's pick up where we left off. Yesterday, we got us some properties of definite integrals. I always feel like I'm so close to you right here. You feel that awkwardness?
Yeah.
Yeah. Like personal space.
Yeah.
That's why I try to finish up.
Back there.
Yeah. I think I just have to move them that way more. Just a little bit, I think.
I think we should get a space heater in here.
Yeah. I'm going to work on bringing in a propane gas, fireplace.
Oh my gosh.
I'm feeling it.
I would
Just don't tell the school
I would
board.
donate to that fund.
Can I bring in my own space heater?
Okay, now I can move to the other side. Okay. All right, what was the answer to the first one? 0. And we justified that in a couple of ways. Okay. I like the f of a minus f of a, or f antiderivative of f of a minus that. All right, and then what do we say for this one? Right. And we explain that in a couple of ways. If you use the fundamental theorem, this one is f of a minus f of b. This one is f of b minus f of a. They're just opposites of each other. So therefore, that's the missing link here. All right, in the third one, we'll say the integral from a to b of k times f of x dx is equal to, where here k is a real number. Stop, think about it, and tell me what you think this is. What's something that would be equivalent to that, but it doesn't look exactly the same? Take the k out and put it in the front. So that's what we have. So something is only true if we believe it to be true. So is that true? Okay. Sure. Why? Okay, so if we think about it really simply, maybe I have a function y equals 2. Okay, so that's my function. All right, and I go from, I don't know, 1 to 5. Okay. Okay. What's the area under the curve? It's equal to 8, right? Area is equal to 8. Okay, that's like maybe that's the integral from f of x, or a to b of f of x dx. Well, if I multiply y times 3, so I get y equals 6. That's my new function. Okay, and then so here's 6. What's the area here? So it's 6 times 4, that's 24, that's 3 times it. Okay, this is a simple explanation that justifies that the integral of a constant times a function is equal to the constant times the integral of the function. Yes. Loving it. Okay, so proof here. If we say this, this first, the left side, okay, we'll do both of these here. The left side of this is k times f of b minus k times f of a, correct? That's the left side. And then on the right side, it's k times f of b minus f of a. Love it. Okay, that's a really, this would be a mathematical proof to say, yeah, that demonstrates that they're same because we're just using the distributive property. Okay. All right, another one. If A is less than C, which is less than B, then the integral from A to C, pardon me, A to B of f of x dx is equal to. Yeah.
The integral of f of x from a to c plus from c to b.
Okay, I'll write it down. Integral from a to c of f of x dx plus the integral from c to b of f of x dx. We have something out there. Is this true? Can we do this visually? So let's just say I've got some A here, some C here, some B here. And so, I don't know, my function is whatever. Okay, it's f of x. And if I look at area here, 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 okay, does this picture match this integral, this equation right here? You take this area plus this area, you're going to get the total area here. What's also cool is it doesn't matter if these are positives or negatives, it'll still match up. Okay, mine just happen to be above the x-axis, but they could go up and down wherever they want to be. That's the key. All right, so these are some properties of integrals that we're now going to apply to a so here's a worksheet. There's two sides. I want you to get going on it right away. You can work with a partner on this. I see what you're doing.
I don't know what you're talking about.
We have to put the star on the stage. Come on.
I'll have to think of better ones. In reverse.
Yeah. All right, it's not your eyes. It's not your eyes. That worksheet is blurry. Okay? I cut those out of the online version. These are out of your textbook, so they're problems that were similar too. So let's just take a look at the first one. All right, the graph consists of line segments as shown in the figure. Evaluate each definite integral by using geometric formulas. So look at this first one. The integral from 0 to 1 of the opposite of f of x dx. Okay, so where's 0 and where's 1? Does everybody agree? We're talking about this area right here. Okay, everything that we're going to do in this one has to do with triangles and rectangles and squares and so on. Okay. How come I can't stop? There we go. Okay. So what is the area of this section? Oh, come on. Hey, this is payback. Jamie fell out of her seat.
I pushed her. Well, she's leaning way over like this.
I guess that's what happens when you're just on the edge of your seat in this class.
This is so exciting.
She told me it was backwards on there, and when it processed it, it flipped. So I wanted to see, and then she pushed me over.
Good. All right. So I don't have a lot of room here, but you've got space where you can write it. Why don't I just write it like this? So letter A starts off as 0 to 1 of negative f of x dx. Okay? I want you to try to use proper notation as you're writing these. Does this make sense that I can write this as negative of 0 to 1 of f of x dx? Is that legal? Which rule is that back there? Number 3. Okay? Because negative 1 is the k. So all I have to do is figure out what this is, and then the answer is going to be the opposite of that. You know what I'm saying? Okay, what's the area of this triangle? Did you figure it out yet? 1/2 times 1 times 1, right? So the area of that little triangle is a half. You're going to use the numbers in here. So the answer here is negative 1/2. And that's the answer to the first one. Make sense? Okay, do all the rest. You're going to find yourself making triangles or rectangles or trapezoids.
The area, no. You can't have it.
Oh, my bad. My bad. The area is 1/2. However, because it's below, the integral here is negative 1/2. So it's totally my mistake. Is equal to opposite of negative 1/2. Final answer is 1/2. Now remember, right, you're not finding the area, you're finding the integral. This integral, no matter if you find this integral from 0 to 1 of f of x dx, it's going to give you a negative 1/2. So the answer is the opposite of negative 1/2. Final answer, 1/2. Thank you. Okay. You're going to work on both sides.